All right, so for example number 1, picking up where we left off, and this is where video timed out 7th period. So all that we did, again, just kind of recap this. Again, we started off, again, not in standard form. So recognizing at this point, we don't know if it's horizontal or vertical, not until we get into standard form. So all that we're going to do is we're going to regroup to where we have the x's together, we have the y's together. I'm going to move that constant to the right side. And then we're going to try to complete the square. We said before, completing the square, especially on the y term, we had to factor out the 4. So we've now completed the square. We've added the, like I said, the 9 to the other side. Again, from here, added the 9 to the other side. We didn't want to fall victim to thinking I'm adding 1 on the left, so I should add 1 on the right. It's really 4 times 1, so that's why I added 4. Now, again, looked ahead just a little bit, I guess. But if this is where we were at this point, when we start to combine things, we know that on that on that right side, the -9, the +9, they're going to cancel out, and it's going to get us 4. But on the left side, again, the whole reason for doing this, again, we want to get our binomial squared. So we know that x squared plus 6x plus 9, what multiplies to 9 adds to 6. We're thinking about x plus 3 times x plus 3. So more efficiently, we write it as x plus 3 quantity squared. Similarly, over here, we have 4 times, let's see, y squared is going to split evenly, multiplies to 1 adds to -2. We're thinking y minus 1 times y minus 1, more efficiently written as y minus 1 quantity squared. And again, that's equal to 4. So if we think back to our standard form, whether it's horizontal or vertical, as you can see, we're equal to 1 on the right side. That's a non-negotiable thing. So what I mean by that is that if you have anything other than 1 on the right side, we have to turn it into a 1. We have to make it a 1. So as we're looking at this and we see that we have 4, we have to make that into a 1. So the way that we're going to go about doing that algebraically is that we're going to divide by 4. There's a catch, though. If you divide the right side by 4, we have to divide everything on the left side also by 4. Now, some people may not see it initially. We might look at this and think, well, wait a minute. We're supposed to get our denominators, and I see that's where we're going, or that's what we're creating. But in order to really pull this off, deciding horizontal versus vertical, that's going to take place based upon which denominator is larger. Well, we just haven't cleaned it up yet. So on the left, my x plus 3 squared. All right, sorry, there's a slight interruption. Again, back to this problem. So like I said, the binomial on the left, the x plus 3 quantity squared over 4, that one's as good as it's going to get. Nothing can reduce. But when we move on to the second, as we see, we have a 4 over 4. So that's going to cancel. We definitely want to be sure, even though it may feel a little like overdoing it, but we definitely want to write that as being over 1. Remember, we want to see this as a fraction. So this is where we're at in terms of the standard form. We have it. Now at this moment, now we absolutely can identify whether it's horizontal or vertical. Remember, what we're looking for is the larger denominator under the x term, or is the larger denominator under the y term? So when I'm looking at my denominators, 4 and 1, obviously 4 is larger. So 4 is under the x term. That makes this a horizontal ellipse, excuse me, which means that my template, if you will, what I'm creating here is x minus h squared over a squared plus y minus k squared over b squared is equal to 1. So again, on the left is our reality, on the right is our template, and now we just need to match these up so we can identify h, k, a, b, and c. So remember, the pieces here that are always going to be the same here is that h is always the amount that I'm subtracting from the x term. So as I'm looking at this, x plus 3, it's really x minus -3, -3 for h. K is the amount being subtracted from the y term, so y minus 1 very clearly identifies that k is 1. A, B, and C. All right, now just looking in the correct location. We had said previously that A is larger than B. Therefore, A squared is going to be larger than B squared. That's why we were able to identify this as a horizontal ellipse. So we're saying that A squared, that's going to be equivalent to 4. And if that's the case, a little bit of math, we square root both sides, and now we know that A is the square root of 4, or 2. Similarly, we know that B is going to be the smaller piece, so b squared is going to be the smaller denominator. We now know that b squared is equal to 1. Same thing here, square root of both sides. We can say that b is the square root of 1, which is 1. Now, as we're looking up there, C is not going to come from the standard form of the equation. What we knew is that C squared is equal to A squared minus B squared. And by knowing this, now we can say that C squared is equal to, we know A squared, the larger denominator. We know that A squared is 4. We know B squared, the smaller denominator, is 1. And as we do the math here, C squared is equal to 4 minus 1 is 3. Square rooting both sides, and now we can see that C is the square root of 3. All right, so now we have done it. We have all 5 of our variables, H, K, A, B, and C, and now we can go ahead and start answering the question. So first question is to identify the center point. So the center point is simply HK, so H is -3, comma K is 1. My vertices, they are going to be A units away from the center point. So I should plot this center point, of course. -3, 1 is right there as my center. So if this were a vertical ellipse, the vertices are going to be A units above and below the center point. But since this is horizontal, the vertices are going to be A units to the left and to the right. So as we can clearly see, A is 2. So from the center point, I'm going to move to the left 2, put a vertex. I'm going to move to the right 2, put a vertex. So my vertices are going to be located at -5, 1 and at -1, 1. These are my vertices to go along with the center point that we've already calculated. Next up is going to be the endpoints. So my endpoints, remember the endpoints, again very appropriately named, they're the endpoints of the minor axis. We said that this is horizontal, so my minor axis is actually perpendicular to the major axis. So my minor axis will be vertical, again, specifically B units above and now below. So B is 1, we're going to go 1 unit above center, 1 unit below center, and those will be my endpoints. So coordinate-wise, we're at -3, 2, and we are at -3, 2. So we have our endpoints. And now at this moment, we can actually draw in the ellipse. It doesn't have to be anything more than that. Now, before we say, wait a second, what about the foci? We absolutely need to calculate the foci, but we don't need to plot them. They're going to be about very roughly here and here, but you're going to see why here in a minute. We don't need to really stress about where we're plotting these things. So if we think about the foci, it's going to, again, being a horizontal ellipse, it's still going to be now C units to the left and to the right of the center point. So remembering, of course, that the center point is at -3, 1. If I'm moving to the left, C units, if I'm moving to the left, √3, wouldn't we just think about subtracting √3? If I'm starting at the center point of -3, 1, if I'm moving to the right of the center point, I'm going to add √3 to my x component. That's 3, 4, 9. And these, then, are my foci. So, as we talked about in class, under no circumstances do we ever want to leave those but to put those in decimal form. We always must stay with exact values. And that's going to be very difficult for us to exactly plot -3 minus √3, 1. That, again, I'm not saying it's impossible, but it would be a ballpark, approximately here, approximately there sort of sketch. And that's exactly what we've already done anyway. So we've identified the center, the vertices, the endpoints, the foci. We have our sketch. The last thing that we need to do is to calculate the eccentricity. So remember, eccentricity, I'm going to do this off to the side. We say that E is equal to C divided by A. So for our purposes, in this case, we know that C is √3. Divide that by A is 2. Nothing reduces, so we're done. Obviously, if we could reduce that fraction, we would. All right, so the last problem that we have, again, and by the way, that's complete. Last problem that we have is going to be very, very similar. What we're going to start with in this particular problem, as we always do, is we're going to regroup. So we've got 9x squared plus 36x plus 4y squared minus 8y. And I'm going to move my constant over so I have -4. So now in both cases, on the x term and on the y term, we have some factoring to do. So if I factor the 9 out, that's going to leave me with x squared plus 4x. If I factor the 4 out, that's going to leave me with y squared minus 2y. Let's go familiar with the last one. And I still have my -4. So now we're completing the square. It's all about b, as you are well aware. In this case, b is 4, so 4 divided by 2 is 2. Squared is right back to 4. But don't for a moment assume that we're adding 4 on the left side. It's really, with my scalar, it's 9 times 4. So I'm actually adding 36 on the left, so we have to match that and add 36 on the left. As we go over here to the y component, b in this case is -2. -2 divided by 2 is -1. Squared is 1. But once again, we don't really have the ability to say that we're just adding 1 to the left side. It's really with the scalar 4 times 1. So I'm going to add 4 over here. So completing the square has been accomplished. Now we need a factor. So what multiplies to 4 adds to 4. That's when we say that we have quantity x plus 2 quantity squared. Similarly, we have 4 times, again, what multiplies to 1 adds to -2. We're going to say that that's going to be y minus 1 quantity squared. And I think at this point it would be appropriate to combine here -4 positive 4. They cancel, and we're equivalent to 36. Which is great, except we can't afford to have a 36 here. We need to have 1. So I need to get going on dividing everything by 36. And when we clean this up, when we divide the left and the right side by 36, the 9 over 36, that's going to reduce to 1 over 4, so that's going to put me at x plus 2 quantity squared over 4, plus the 4 over 36 is going to reduce to 1/9, so y minus 1 squared over 9 equals 36 divided by 36 is 1, and that was kind of the whole point. All right, so move that graph down a little bit, because now, at this point, we can identify where the larger denominator is located. So my denominators are 4 and 9, and quite obviously 9 is the larger. The larger denominator is under the y term. That makes this a vertical ellipse. So if this ellipse is vertical, we think about our template here. We still have quantity x minus h squared, but now it's over b squared, plus y minus k squared. That's over a squared, and that's going to be 1. So as we get going as quickly as possible and identifying h, k, a, b, and c. H is the amount being subtracted from the x term, so h is -2. K is being subtracted from the y term, that is 1. So -2, 1 is my center point, plot it there. A is, well, if a squared is equal to 9, we now know that a is going to be the square root of 9 is 3. If b squared is equal to 4, square rooting both sides, we know b squared 4 or 2. And we know that c squared is equal to a squared minus b squared. So as we plug in, we know that a squared is 9 minus b squared, which is 4. And quite obviously, 9 minus 4 is 5. And now when we square root both sides, we can say that c is 5. All right, so all of that work, you're going to feel like it's practically a sprint to figure out h, k, a, b, and c. I already plotted the center point, but I never actually defined it here. So the center point, hk, is located at -2, 1. That's already been plotted. My vertices, again, remembering, of course, that this is vertical, so now we need to move a units above and below center. So I'm going to go up 3 units, up 1, 2, 3. I'm going to go down 3 units, down 1, 2, 3. So my vertices are now located at -2, 4, and -2, -2. So I get boxing these up. We have the center, we have the vertices. Next up are the end points. So again, if my major axis is vertical, my minor axis, the end points are going to be bookmarking. That's going to be horizontal. So we're going to move b units to the left and to the right. So if b is 2, we're going to go left 2 from center. We're going to go right 2 from center. And those endpoints are going to be located, if I'm counting correctly, at -4, 1, and at 0, 1. These are my endpoints. And at this moment, we could actually draw in a decent ellipse. There it is. Next up, we need to figure out the foci, where they're going to be located. Remember that our center point is at -2, 1. And if I go below, if I drop down c units, which is root 5, I'm just going to subtract root 5 from the vertical, from the y term. -2, 1 is my center point. If I were to go above, I'm just going to increase root 5. Like I said before, if you wanted to plot these, again, very roughly sketched in there, that's purely optional. But those are the foci. We have our sketch. Last thing that we need to do is figure out our eccentricity. Let's get a little bit more space here. Eccentricity, remember c is root 5 divided by a, which is 3. Nothing reduces, so that's our finish. All right, so guys, your homework assignment can be found on page 710. Again, let me know if you have any questions on this stuff.